All right, so now let's continue with this. So right now, so what I'm going to do, I'm going to introduce another thing which is called electric field. All right, electric field. Yeah. So we are going to have electric field. Electric field. I believe you know what the field is, but because you are doing physics, you think like you don't know what is a field. If I were to ask you, do you know the soccer field? You're like, yeah, it's the ground where they play soccer. That's what it is. It's a place. Field is a place. Ne? Yes. So when you say electric field, we are talking about a place where there is a field. We good, ne? Yes. All right. So here, actually, because you are dealing with what we call electrostatic, you are dealing with the force by charges, pull or push. So here we're talking about the place where the charges will experience or feel, they will sense a push or a pull, the force by the electrons. Can you see that? If I put you in a room and there is a heater, if you are closer to the heater, you are closer to the warmness. That means you are in the space where there is warmth. Space, field. You are in the warm field. You see that? Yes, but if I push you away from the heater, maybe say 4 steps, you might still feel the warmth, but the warmth is a little bit less. You are within the warm field, but the field is now lesser because you are far away. We good, ne? Then I separate you, I put you to be 1 kilometer away from the heater. You no longer feel that heat. You are away from the area, from the field of the heat. Is that making sense? Yes. Okay, good. So now there is a way how we represent the field. But first, let me give you the formula. So the formula, they say electric field, they're using E. I want to go back here. All right, there it is. I did put the arrow there because I love to put arrow in everything that is a vector. So electric field, it is given by the force. Which force? The electrostatic force divided by the charge. Now I'm going to add this. That charge, normally they call it a positive test charge. I'm just giving you. It's actually F over Q. That's all. Okay? Yeah. That's the formula. But there is another formula also. I'm going to explain the difference. Now, here's the difference. I'm showing you how we're getting the formula. So that means if I take electric field and I make it equals to, and I'm saying I want to put the formula for the electric force. You see that the thing, am I right? Ne? Yes, sir. Yeah. So now what I'm going to do, I'm going to substitute in place of that, which means I need to take this big formula, this one here. So I need to put it right on top here and then divide it by that charge. Can you see that? All right. So that means I can go K and then Q1 and then Q2, and then I can write it divided by the R squared. Now I'm supposed to do this divided by that Q, but the formula will look bigger. So what I'm going to do, I'm just going to write it next to it. I'm going to use that division, the other type of division, this one. I can say divided by the Q. Can you see that? Yes. We know it's that Q, the positive test charge. Now, mathematically, we say if you've got a division, like here, you can make a division a multiplication and write that Q upside down. I get it? All right, so now I'm going to remove that Q. I'm going to write it upside down, which is 1 over the Q. Now they tell us the Q will cancel 1 of the Q. Now your formula, I'm writing it in turquoise blue. So it will be electric field equals to K. That Q1, we can just write it as just Q all over R squared. So I'm going to put this formula in the box. That's the one you needed to know. And also that one. Those are the only 2 formulas. Can you see? Now let's explain what is a different. Okay? Now this one, when you compare with this, do you see this one has the R, the distance? Ne?
Yes.
This one does not have the R. So this one means if I have a charge, let's call this charge, let's call it charge A, like that one. So which means we can call it QA, ne? Yeah. And then it's QA. So it means if I ask you what is the electric field by charge A, where charge A is, where it is found, where it is located, where it is at. You get it? Yeah. So if you want to calculate the distance from charge A to charge A, do you have any distance from charge A to charge A? You can't even move, ne?
Yes.
So you use this one. So this is the electric field where the charge is. Where the charge is at. All right, so let's continue in the next video.